Angle side, yes.
Angle side.
Alright. I would probably advise writing some of these first things down that we take a look at here. Okay, this first section, we're going to start by verifying trigonometric identities. Okay, to do that, we first need to look at a few properties. These are ones that we've already talked about. Okay, our reciprocal identities and our quotient identities. Okay, where cosecant and sine are reciprocals of each other. Secant and cosine are reciprocals of each other, and tangent and cotangent are reciprocals of each other. And then also, we know that tangent is sine over cosine, and cotangent is just the reciprocal of that, cosine over sine. Okay, so we talked about these in the last chapter, but we're going to use them a lot in this first section. So take a minute and write these down in your notes. It does that. There is science behind if you write stuff down, it helps you remember it. So even if you have this written down somewhere else, it's still a good idea to write it down again. Sure. All right, we have these broken down. Okay, sounds good. All right, so a couple other identities that we're going to use in this section are the Pythagorean identities. Okay, these are not really ones that we've talked about yet. Okay? The main one is this first one: sine squared plus cosine squared equals 1. Okay, so I put the unit circle on this slide just to show how this works. Okay, this isn't really a proof of a Pythagorean identity, but it's just going to show how it works for a few angles. Okay, so if I choose pi over 6 as my angle, okay, 30 degrees. So I want to calculate sine squared of pi over 6 plus cosine squared of pi over 6. Well, we know that sine of pi over 6 is the y value there, that's 1/2. So this is going to be 1/2 squared plus cosine is square root of 3 over 2 plus the square root of 3 over 2 squared. Well, 1/2 squared is 1/4. The square root of 3 over 2 squared, that would be 3 over 4. 1/4 plus 3/4 is 1. Right? This ends up working for every single angle. Right? If we take the sine value of an angle and square it, and add the cosine value of that same angle squared, we will always get 1. Okay? So these other two identities, 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared, are just manipulations of this first one. So if I take sine squared plus cosine squared, equals 1, and divide every term by sine squared. And I can do that because what I'm doing to one side of the equation, I'm doing to the other. If I divide every term by sine squared and simplify, so sine squared over sine squared would just be 1. Cosine over sine, that was one of our quotient identities that we just talked about on the last slide. Right? So cosine over sine is cotangent. So this would be cotangent squared of x. And then 1 over sine, again, talked about on the last slide, is a reciprocal identity. 1 over sine is cosecant. So this would just be cosecant squared of x. So that's where this one comes from. Okay? All we're doing is taking our original Pythagorean identity and dividing each term by sine squared. Right? We can do something very similar to get this one. I can take my original Pythagorean identity, sine squared plus cosine squared equals 1, and divide everything by cosine squared. So if I divide every term here by cosine squared, sine squared over cosine squared, well, sine over cosine is tangent, so this will just be tangent squared. Cosine squared over cosine squared would just be 1. And then 1 over cosine, we know, is secant. So 1 over cosine squared is secant squared. So that's how we get that version of the Pythagorean identity. Right? So all three of these are very closely related. Right? If we start with sine squared plus cosine squared equals 1, we can easily derive these other two. Right? Now, also, we may end up using other manipulations of all of these. I can add or subtract pieces to other sides of the equation. For example, in this first one, sine squared plus cosine squared equals 1, I could subtract cosine squared to the other side and say, well, sine squared then is equal to 1 minus cosine squared of x. Right? Those types of manipulations we will use in this chapter as well. Right? For this one, right, I could subtract tangent squared over and end up with 1 equals secant squared of x minus tangent squared of x. I could subtract the 1 over and say tangent squared of x is equal to secant squared of x minus 1. Okay? So what we're going to be doing with these identities, right? We're going to be given an equation and just asked to show that one side of the equation is equal to the other by manipulating and using Pythagorean identities, quotient identities, and reciprocal identities. Right? Questions so far? All right, then let's try some. So I guess this slide just kind of says what I just said. Okay, to verify trigonometric identity, we are just going to take one side of an equation and manipulate it until we get to the right side. Okay, so I guess this last line is kind of important here. It's not taking an equation and doing the same thing to both sides. Right? I'm not going to divide both sides of the equation by sine or something like that. I'm going to take one side of the equation and try to manipulate it using my identities until I get it to look like the right side of the equation. Yeah, you definitely did this in pre-calc. So let's try some. Okay. So we've got got cosine squared minus 1 over cotangent equals cotangent. Okay? What I want to do is take the more complicated side, so in this case that's the left side of the equation, and try to simplify it to make it look like the right side. Okay? There are a few different strategies that we can use to do something like this. Right? One is using our identities right off the bat. Okay, so in the numerator of this fraction, I see cosecant squared minus 1. So, like we just talked about on the last slide, 2 slides ago, I guess, we may end up using manipulations of these Pythagorean identities. So, right here, if I subtract 1 from both sides of this equation, I end up with cotangent squared of x equals cosecant squared of x minus 1. So this is what's showing up in the numerator of our problem, cosecant squared minus 1. So what I can do is replace that whole thing, cosecant squared minus 1, with cotangent squared. Okay? So, cosecant squared minus 1 is just equal to cotangent squared. So this becomes cotangent squared of x over cotangent of x. Well, how can I make that then cotangent? So I've got cotangent squared over cotangent. Cotangent squared is just the same thing as cotangent times cotangent, right? So, I mean, I don't have to, but I could write it out like this. Instead of cotangent squared, I could write it as cotangent times cotangent, so that we can see one of the cotangents will cancel out in the numerator and denominator, and I'm just left with cotangent. So that's how we would verify an identity, okay? Showing the steps, that prove one side of the equation equals the other. So in this problem, we just had to use one of our Pythagorean identities and then cancel something out. Questions so far? All right, let's take a look at another one. So, one of the more popular strategies to approach these types of problems is to rewrite everything in terms of sine and cosine, right? No matter what the trig function is, I can rewrite it in terms of sine and cosine. So, in this one, we've got cotangent to the fourth plus cotangent squared equals cotangent squared times cosecant squared. So let's start with the left side here and rewrite this rewrite everything in terms of sine and cosine. So cotangent we know is equal to cosine over sine. Right? So I could rewrite that first term as cosine to the fourth over sine to the fourth. And then similarly for cotangent squared, I could rewrite that as cosine squared over sine squared. And again, somehow we want this to equal cotangent squared times cosecant squared. Well, I've got two fractions here. Let's try to add them together. Right? In the right side of the equation, this is just one term. So we're probably going to have to add these together somehow. Well, to add fractions, we need to get common denominators. So to make these denominators the same, I'm going to have to multiply this one by sine squared. Right? So I can multiply this whole term here by sine squared over sine squared. So we'll end up with cosine to the fourth over sine to the fourth plus cosine squared times sine squared over sine to the fourth. I'll keep writing out this side here so we remember what we want this to equal. So now I can combine my fractions. Write this as cosine to the fourth plus cosine squared times sine squared all over sine to the fourth. Now if I look at my numerator, both of my terms have cosines. I could factor out a cosine squared from each of those terms. Okay. If I factor out a cosine squared, I'm going to come up here, I'll have cosine squared of x, and then I'll be left with cosine squared here. And then over here, I would just be left with sine squared. That's all still over sine to the fourth. What? Okay, so what don't you understand? So if I think about this as like x to the fourth plus x squared y squared, right? Something to the fourth plus that same something squared times something else squared. I'm just factoring out an x squared here. When I do that, when I factor something out, that's dividing. Right? So if I take x to the fourth divided by x squared, I would just be left with x squared. And then if I take x squared times y squared divided by x squared, I would just be left with y squared. Okay, that's all we're doing here. I took a cosine squared out of each of these terms. So I'm left with cosine squared, my first term, sine squared, my second term. We okay? And again, this just still equals cotangent squared times cosecant squared. And that's what we're trying to show. Well, what are you confused about? What do you mean? Why is the cosine squared just cosine? Which one are we looking at? The one that we factored out?
Yeah.
So the largest power I could take out of both of these would be an x squared. So that's what I did. I took out an x squared, or cosine squared.
Those are like
So now I see a Pythagorean identity. I've got cosine squared plus sine squared. That's just equal to 1. So this just ends up becoming cosine squared over sine to the 4th. Right? This whole thing, cosine squared plus sine squared, is just equal to 1. Right? That's our Pythagorean identity. And again, I still want this to equal cotangent squared times cosecant squared. So, I just have squared terms over here. Right? What I can think about doing now is rewriting the denominator as sine squared times sine squared. Right? So, I can split this up into cosine squared of x over sine squared of x times 1 over sine squared of x. Okay, all I did was split the denominator up, sine to the 4th into sine squared times sine squared. So now, cosine squared over sine squared is one of our quotient identities. Cosine squared over sine squared is just cotangent squared. And 1 over sine squared, we can rewrite as cosecant squared. Okay, so this one was a little bit tricky. Okay, there's a little bit to this one. But all we're doing is manipulating one side of the equation using our identities to get it to look like the right side or the other side. We could manipulate either side of the equation.
So we took out the squared, why did it become x squared plus y squared instead of x squared times y squared? That's the only way.
So these terms are still separate terms. So what we're doing, when I take something out, we're essentially dividing each term by that. So if I'm taking an x squared out, I'm dividing this term by x squared, I'm dividing this term by x squared. So here, x to the 4th divided by x squared is x squared. Here, these x squareds just cancel out, and I'm left with y squared. That addition is still staying there.
You used to do that every time we're using the x squared line. Like if you have two multiplied by each other, this becomes plus. You upset. So is cosine squared plus sine squared 1?
Yes. Yeah, that's how we went from here to here. Right? This, I guess we could
Okay.
show that that's times
And then
1.
More slow. And then you split that up in the next one.
Yeah, because I recognize that we just have squares over here. So I split the sine to the 4th up into just sine squared times sine squared. So then we end up with cosine squared over sine squared. Yeah, as long as you're multiplying, you can always split things up like that. That's essentially what simplifying a fraction is.
Oh yeah, I didn't know that. It's just weird looking at it this way. It's just like
Right? If you have 9 over 12, what you're doing is splitting this up into 3 times 3 over 4 times 3.
oh, and then you just know that 1 over sine is cosecant. And then cosine over sine is cotangent. I don't know.
Other questions on this one? So maybe we should have done a few simpler ones before this one.
I think so.
So why don't we try some simpler ones here?
Are there multiple ways you can do this too?
Oh yeah.
Okay.
Yeah, so for these, there's lots of different ways that you could get to the right answer. Right? There's not one correct answer. So these are hard for me to make up. So I gotta look some of these up here. There isn't even a trick function. All right, how about something like this? Sine times cotangent plus sine equals. All right, how about something like this? Cosine times cotangent plus sine equals cosecant. Right? So, again, like we did in the last problem, which ended up being kind of complicated, one of our more popular strategies is to convert everything into sine and cosine. Okay, so if I take this left side of the equation, the only thing I would have to convert is cotangent. Right? So I could rewrite this as cosine of x times cosine over sine plus sine of x. And I want that to eventually equal cosecant. Well, what I can do then is actually multiply these together. So I would end up with cosine squared over sine plus sine of x equals cosecant of x. So, I guess the answer is no. Does anybody see a way that we could maybe manipulate one of these pieces to get to a Pythagorean identity? Cosine over sine is cotangent. Yes. Say it again. So, yeah, we've got two terms here. Let's try to add them together. To do that, we need common denominators. So, this term here, I can multiply by sine over sine. Right, so let me go over this here. Times sine over sine. So when I do that, I'll have cosine squared over sine plus sine squared over sine. Then I combine these into one fraction. Right? Cosine squared plus sine squared over sine. Now, we know cosine squared plus sine squared is just equal to 1. So we end up with 1 over sine. So if we would just be going back to here if we divided both terms by sine. So then we know one of our reciprocal identities, 1 over sine, is cosecant. So these problems, there isn't one process to do them. Right? It's not, here's the formula, plug in numbers. Right? These we have to do a lot of thinking and manipulating, and you may go down a wrong path. Right? Sometimes you may have to restart. You're just trying things and seeing if it works. Right? Using our identities to manipulate things until we can get to the other side of the equation. We're not skipping this lesson.
So, what's cosine squared divided by sine?
Well, I mean, we've manipulated that, right? So we could say cosine squared divided by sine is the same as cosine times cotangent.
You start from where it's cosine squared x plus sine squared x. Cosine. Okay. And you do that part.
Cosine squared plus sine squared is one of our Pythagorean identities.
Oh.
So that's just equal to 1.
I didn't see that. As we were dividing cosine squared minus sine, I was lost.
No, we were just saying that this whole thing is our Pythagorean identity. It equals 1.
How do you know when you're
When the left side looks exactly the same as the right side. Alright. Questions on that one? Alright, let's try another one here. Alright, how about this? Cosine squared times tangent squared plus cosine squared equals 1. Okay? Now, we've got a couple of strategies. The one that we've worked on in the last couple of problems is just converting everything to sine and cosine, going from there. Something else we could do is factor. Right? We used factoring in that long, complicated one. But in this problem, I see a cosine squared in each term on the left side here. Well, we could start by factoring out a cosine squared. So this could become cosine squared of x times tangent squared of x plus 1. This, we've got a 1 and one of our functions squared. Kind of looks like maybe a manipulation of one of our Pythagorean identities. So is tangent squared plus 1 something fancy? It's secant squared, right? So this can just become secant squared. So cosine squared times secant squared. Well, now, secant squared is just the same as 1 over cosine squared, right? So this can become exactly cosine squared times 1 over cosine squared. So I'll write out this cosine squared over cosine squared That's just
That's clicking.
1.
Very good.
So, some big things to look for, right, are whenever we have some kind of manipulation of one of our Pythagorean identities, whenever we can factor something out, another strategy is just make everything in terms of sine and cosine and see what you can do from there. Right? Now, we could have done that with this problem, right? I could have made this, here's a totally different way we could have done this. We could have, right off the bat, changed tangent squared into, sine squared over cosine squared. Well, here, then the cosine squareds would cancel out. And we would just have sine squared plus cosine squared. Which, that is one of our identities. Sine squared plus cosine squared just equals 1. Yeah, so in this case, that way it was saving us a few steps, okay? So for all of these problems, there's multiple ways to make one side of the equation look like the other side, okay? We just have to start trying things, start using our strategies, okay? There isn't one way, one process to do all these problems, okay? Which is why this is probably my favorite section in trigonometry, because you got to think. There's not plugging numbers into a formula, right? It's you gotta think. You gotta try different things. You gotta just start trying until it works. Okay? Questions? All right, I think we have time maybe for one more. How about? Yeah, I'm gonna have you guys try a few of these here. What's up?
You can just leave my test on your desk if you want. It's my study hall's in
Okay. Alright, how about sine of x minus cosine of x times sine of x plus cosine of x equals minus 2 cosine. Alright, how about something like this?
So sine plus cosine is 1.
Sine squared plus cosine
Can you
squared is
square it?
that would
Oh.
change the value.
You can't just square both sides.
Well, we could, but we would have to square
Okay.
this whole
I
thing.
forget it.
Yeah. So, in this problem, well, since it's set up as a binomial times a binomial, let's just go ahead and multiply it out. Alright, let's multiply out the left side.
Sounds like a
Okay, so double distribute or FOIL, whatever you want to call it.
sine.
So sine times sine would be sine squared. Sine times cosine. That's right, is sine times cosine. Then negative cosine times sine minus cosine times sine. Then minus, so negative cosine squared. All right, so let's see, what can we do here?
Cancel off the sine. Those two.
Yeah, so we've got sine times cosine, and then negative cosine times sine. That's the same thing, right? So we just end up with sine squared minus cosine squared. Yeah, equals 1 minus 2 cosine squared. So sine is 1 over cosecant. So if we think about what we have here, I want to turn this just into cosine squareds, right? The right side of the equation just has cosine squareds. So if we think about our Pythagorean identity, cosine squared plus sine squared equals 1. Well, I can manipulate this. I can solve for sine squared by subtracting cosine squared over. So sine squared of x would equal 1 minus cosine squared of x. So again, thinking that we just want cosines, I can replace sine squared here with 1 minus cosine squared. Excuse me, 1 minus cosine squared. So this become like this, okay? Sine squared is the same as 1 minus cosine squared. So 1 minus cosine squared minus cosine squared. These are like terms, right? So I can just combine them. That would just be 1 minus 2 times cosine squared. Right, so these problems are all just about using our identities, trying. I mean, you may have to try different things, right? If you don't recognize that you could rewrite sine squared as 1 minus cosine squared, you might have to try something else, okay? Just using the identities, replacing different pieces with what we know to be equal, right? So I do want you to try a couple of these. Page 627, numbers 31 to 41 odd. 31 to 41 odd.